Okay. We're going to talk about lesson 7 and 8. So here we go. Okay. What's important here is that we're going to start combining all these transformations together. So it can get a little bit hard. This first part talks about all the different replacements. We replace x with x minus h or y with y minus k. That's translating it things left and right and up and down. So when you replace them with, you're adding or subtracting values from the x's and the y's, you're going to shift this left to the right. And we can, the third bullet here, or second bullet here, is that we can also reflect them over the different axes. And last, you can actually stretch them vertically and horizontally. So all three of those are going to go together. There's some things to note here. When you, if we were to do this, it says stretch the image of the function after horizontal stretch by a factor of 3. And then we're going to follow that by a vertical stretch by a factor of 2. So if we stretch this horizontally first, what was that? 2 now becomes 6. So you get these points out here like this, and it goes like that. That would be the first stretch, factoring, timesing it by 3. And then we're going to do a vertical stretch by a factor of 2. So all the y values will be times by 2. So this point that's at 2 becomes 4 right there. So all of a sudden, these values on the x-axis here, the y values there are 0. So nothing changes there. 0 times 2 is, so this just looks like this now. Okay, so we have that highest arc. Let's see if it matters which order we do it in. So letter B says, sketch the image if we do a vertical stretch by a factor of 2 first. So all the y values will be multiplied by 2, all the points. So this 2 becomes 4. I'm going to use a different color this time. And then, now we're going to do horizontal stretch by a factor of 3. So take all the x values. This 2 times 3 is 6. Does it change? Oops. No. Our final result is exactly the same. Okay, so whether you do a vertical stretch or a horizontal stretch, the stretches, nothing changes. All right, let's do investigation number 2. Well, what happens if we do a vertical translation? We're just going to be moving it up and down, and a horizontal stretch. Okay, so first of all, it says sketch the image of the function after vertical translation 3 units up. Okay, so we're going to take this, and we'll move the whole thing up 3 units. Okay. We got calibrate. Okay, so now we are going to go back to that, and so we're going to stretch it, or sorry, move it 3 places up. 1, 2, 3. 1, 2, 3. So we get this little green circle. So that's a vertical translation. And now let's stretch it by a factor of 2. So all the x values change. So 2 becomes 6. Negative 2 becomes negative 6. 0, that doesn't change there. So we end up with the blue line looking like that. Oh, I'm sorry. We're doing it by a factor of 2. You're right. Okay, sorry. I was doing it by a factor of 3. Okay, so you're right. So it only becomes 4. There. Is that better? Okay, now B says, okay, sketch the image if you do a horizontal stretch by a factor of 2 first. So horizontal stretch by a factor of 2. So 2 becomes 4 and negative 4. And then move it up 3. Does it change? Nope. So that was okay. So a vertical translation and a horizontal stretch, order didn't matter. All right, turn the page. How about a vertical translation and a vertical stretch? Let's try. So vertical translation, we're going to move it 2 units down. So quickly do this. 2 units down, and then we're going to do a vertical stretch by a factor of 3. vertical stretch by a factor of 3. So this 0 times 3 is what? Still 0. So this stays there. But this negative 2 times 3 is negative 6. And this one is positive, or I mean, still negative 6 on both sides. So now we get this picture. Okay, let's try B. Sketch the image of the function. If you do a vertical stretch by a factor of 3, so this 2 becomes 6. The x values don't change on the x-axis. And now we're going to move it 2 units down. Do we get a different picture? Yes, we do. Does the order in which the vertical translation and the vertical stretch are performed make a difference? Yes. Huge. Circle that one. Massive. If you have a vertical stretch and a vertical translation, order matters. And let's do the last one down here. What about if we do a horizontal translation and a horizontal stretch? How many of you think that it's going to matter? 1, 2, 3, 4, 5. Rest of you are chickens. Okay, so we're going to sketch the image of the function after the horizontal translation 1 unit to the right. So just take the whole thing, go over 1. That's quick. And then we're going to stretch it by a factor of 2. So negative 1 becomes negative 2. Positive 3 becomes 6. And 1, you have to do this one now. Check this one out. Right here. That's x value is 1, so we times it by 2. So it becomes 2 over here. So now all of a sudden the picture looks like that. Y'all good? Okay, let's do it backwards. Sketch the image of the function after the horizontal by stretch of 2. Stretch it first. So it goes to 4. Does the middle change? No. And then translate it by 1 to the right. Is it different? Yes. This one goes at 3. Well, that one goes at 3. Are they the same? No. What's that? This one should go to 2. Did I do it wrong? Yeah, I never moved that. Oh yeah, 1 times 2 is 2. This one should have gone here. Right? Yeah, so they are different. They are. Go back and do it again if you want, because I messed up, but they are different. You have to do them in a specific order. Okay, so what you figure out here is that when you do vertical and vertical or horizontal, horizontal, order matters. So here's some general rules. It says, in general, the order does not matter when 2 translations are combined. If we're just moving it left and right and we're not stretching, if 2 translations are combined, order does not matter. If 2 stretches are combined, if you're stretching it horizontally and vertically, it doesn't matter. If a translation and a stretch are at right angles to one another are combined, it doesn't matter. So if one is vertical and one is horizontal, it won't matter either. Okay? Reflections and stretches are combined, that's okay. We can reflect and stretch all in one step, really. We can just times it by negative 3 if you want to do that. But here's when it does matter. When a translation and a stretch are in the same direction, so both are horizontal or both are vertical, then it matters if you're doing a translation and a stretch. And most reflections and translations, when they're combined, order does matter. Okay, so unless otherwise indicated, here's our CERT thing again. We had this last semester, stretches, reflections, and translations. If you do them in that order, you'll be good to go, unless they tell you to do something different. Okay, follow CERT. Describe a series of transformations required to transform graph A to graph B. What did we do? Is it a different shape? I always look at that. Is it a different shape looking thing? So if it's not a different shape, you didn't stretch it. So what did we do for sure? Quickly. We reflected. That's the first thing I noticed. Doesn't have to be the first thing you notice, but reflected. And then you translated, right? Where did we go? We're going from A to B. Pay attention to the words. They often put them A and B, but then they'll say, well, how do you get to go from B to A? So make sure you're careful that you don't get tricked into something, okay? We're going from A to B. You reflected it, and then you moved it where? So you might want to just go and reflect this. Just go ahead and reflect this over so you can see. If you reflected A, it would look like that. And now you can see where this little point is. What did you do with it? 2 left. And where else? Up 3. Okay, what if order matter? Does order matter? No, doesn't matter at all. All right. We can similarly do all of these things. Describe a series of transformations required to transform graph A to graph B. Let's do that one. So if you go from A to B, did it change shape? Yes, so we know there's a stretch. Is there also a translation? Yeah, there is. Now, is there reflection? There doesn't have to be. There could be, but if you don't need it, because they're just rectangles, let's not include it. Okay, so let's do our stretch first. So let's make it be the same shape as B, and then we'll move it. Okay, so how are you going to do that? Did it stretch vertically or did it stretch horizontally? Horizontally. We're doing A to B. Yeah. Yep, horizontally. So how far? So you can look at this and go, okay, well, it used to cover 4. It used to be 4 wide. Now how wide is it? 8. So we know it's a horizontal stretch by a factor of 8. Okay, so that would now it makes the same shape. Now get it the same spot. Oh, I'm sorry, factor 2. Yeah, it used to be. Okay, now get it to the same spot. I would take the middle. I would pick the middle of this point, or that box, and the middle of this one, and move that. Move middle to middle. That'll just be the easiest way to do that. So how far? 4 left and 7 down, right? 4 left, 7 down. You all good? Okay. How about if you go from graph A to graph C? Yep, vertical stretch. Factor of used to be 4, now how big is it? 8, so factor of 2. And how'd you move it? Go from the middle to the middle. 6 left. That's a 2, not a Z. 6 left, and how far up? 4 up. Okay, you get the point? Can I stop now?
Aren't there a bunch for B to C?
Yeah. Yes, there are. It has some and it says other answers are possible. Yes, because you can go this way and then this way. You can reflect. You could do a ton of things. This one has a reflection in the line y equals x, so they actually flip it over first and then translate 8 units left and 1 down. Tons of different things you could do with that one. You could actually go from, what are we going from B to C? Yeah, you can from B to C, you could shrink it horizontally and stretch it vertically, and then just move it up. I think that's way easier than flipping over the line y equals x. I think that's confusing, but anyway. Okay, so let's go on to the next page. Okay, describe which transformations are applied to a graphical function when the following changes are made to its equation. Okay, so this is replacement. This is why it's so important to understand the replacement terminology. If x is replaced, okay, and does the order in which the transformations are performed affect the final graph? We'll talk about that. So first we're going to replace x with 3x. What is that? horizontal stretch by a factor of 1/3. Now, if we really want to be technical, we should say in the what? In the y-axis. It's always opposite. Good. Okay, that's number 1. What's the second thing that happened? Replacing y with y plus 4 is a vertical translation 4 units where? Down. Correct. Okay, now we're talking about a horizontal stretch and a vertical translation. Does order matter? No. Order does not matter because one is vertical and one is horizontal. Good, go to B. Okay, it says replace x with 2/3 x. So that's a horizontal stretch by a factor of what? 3/2 in the what axis? Y-axis, if you want to be technical. We're going to replace y with -3y. Oh, wow, we have a lot to do here. What's that going to do? Reflect in what axis? X-axis, yeah, reflect in the x-axis. Okay, and what about the 3? Vertical stretch by a factor of 1/3. I won't put in the x-axis. And then the last, no, because you're replacing y with -3y. So watch the replacement value. Yep. And then the x and the x plus 2 means I have a horizontal translation 2 units to the what? Left. Yep. Got it. Good. Now, does the order of all this matter? Yeah, it totally matters, right? Because we have all kinds of stuff happening. That doesn't look like left. It does matter. Okay? It does matter. All right. Gotta get it good. Should we do this? I think, should we just move on? No, move on? Okay, let's move on. Next lesson. Okay, lesson 8. We're going to do it some more, and we're just going to follow this. Now, I told you yesterday, well, I told you yesterday that you needed to make sure you factored out the number in front of the x, which is so important. No, I don't. I just need that. Okay, there. Okay, so make sure you take out this b. Okay, pull out the b. Okay, take out the b. Everything else is exactly the same as we've done before. It says a little stop sign guy says when doing it, we're going to form an equation to the following order. Sketch the original, sketch all the stretches, reflections, and translations. Okay, so it's just good. So when you're trying to say the graph of y equals f of x is shown, that's the original graph, and we want to do these things to it. Oh my word, right? So they like you to make a little list. We'll do it. A is 2, B is 1/2, H is 5, and K, actually probably H is probably -5, right? Yeah. H is -5 if you're going to plug into that, to this formula, and then K is -8. Okay, so write the transformations associated with the parameters. So, okay, what does the A being a 2 mean? We have a vertical stretch by a factor of what? Careful. Nope. 2. If I put it on the right side, right, I'm going to do everything the opposite of the x, but I'm going to do the same thing as the y. So that's a factor of 2. The b being 1/2 means I have a horizontal stretch by a factor of 2. The 5, or the -5, tells me that I'm going to go a horizontal translation, and I'm going to go 5 to the left. And the -8 is a vertical translation, and I'm going to go down 8, correct. All right. So it says put these transformations in an order which can be used to stretch the graph of the function, and then go ahead and sketch it. So can we do it in the order we did? We have it up here. Yes, because we're going to stretch first, reflect which we don't have, and translate. So we're going to do them just the way it says. Yes, ma'am.
Why is it -5?
Because if you put it into this function up here, see how this is a +5, and they automatically throw a negative in it. So for this to turn into a +5, I have to put a -5 in for the 8.
Let's see which way is going to look at the original.
I do. Yeah. Okay, so we can do all of those things. I have colored markers. If you had colored pencils or something, it's great. We're going to stretch it by a factor of 2. Vertical stretches by a factor of 2. So if I have a vertical stretch, this point 0, 0, times all the y values by 2, doesn't go anywhere, right? That one's still there. Pick another point somewhere, like how about this point right there? That is the point 2 and 4, which is now going to become what? 2 and 8, right? So the same thing will happen on the opposite side of this thing. So that's my vertical stretch. That wasn't so hard, like that. Now let's do the horizontal stretch by a factor of 2. So if I take my horizontal stretch, my 0, 0 times it by 2 doesn't change, but the point that is now 2 and 8 up here is going to become 4 and 8, exactly. So 4, now I have a point over here. So I have one in the same spot over here. Okay, good, so that's that one. And I'm going to move it horizontal translation 5 left. Can I go 5 left and down 8 all at the same time?
Yes.
Let's do that. So I'm going to take this vertex, I'm going to go 5 to the left, and down 8 puts me here. I'm going to take this point, I'm going to 5 to the left, 1, 2, 3, 4, 5, and down 8, right at 0. Same thing with the other side. 5 to the left, and 0. Okay, there, I'm done. Not so hard, right? It's all good. Okay, turn the page. Okay, now this one says, I'm going to give you the original graph that has the equation y equals x squared, but I want you to write the actual equation of this given all of these steps. Okay, so I'm going to start with, I need to multiply it by 2. So y equals 2 times x squared, right? Times the whole function by 2. Then I'm going to do some horizontal things to it. I'm going to take my x value. I'm going to put a 1/2 in here. And my x plus 5 is here. And I'm going to square all of this. Yep, and then I'm going to minus 8. Yeah? Yeah, okay, we're not done. Because these two things, this and this, are multiplied together and this is squared. So this could be like this, 1/4. Do you agree with that? If I take this power of 2 and I apply it inside, minus 8. And now this 2 times 1/4, 2/4 is 1/2. So my final answer, I'll write it in red so you can see it, is 1/2. And then x plus 5, well, squared. Hello. Okay, so that's my final answer.
You didn't take it for the square, the 1/2 you take it square.
Oh, I put this 2 went to this 1/2 and to this x plus 5. So that's why it's 1/4, yeah. Okay, all right. I think we can skip down a few. let's go to the next page and see what that looks like over there so we can get on with it. Okay, let's do this one on page 141. It says the function is x cubed is transferred into a new function. To form a new function, g of x is going to be stretched vertically above the x-axis by a factor of 0.25, reflected in the y, and translated 3 units to the right. Write the new equation. Okay, so if you like to stretch it vertically, we're going to have y is going to be replaced. Now this factor of 1/4, you might want to think of it as a fraction instead. So y is going to be replaced with 4y, correct? And then we're going to reflect it in the y-axis, which means the x's are changing. So x is going to be replaced with negative x. And a translation 3 units to the right, we can do that at the end. That's pretty simple, right? So what we're going to do now is that we're going to say p of x, we're going to think of that as being the y, right? And the 4 would be in front of it if you want. Okay, and it's going to be equal to this. Now, we need to, this is happening into my x cubed function, correct?
Where did the 4y?
Oh, okay, well, because it says we are going to stretch it vertically, so vertically is the y value, by a factor of 1/4. So that means I replace y with 4y. Yeah?
Wait, I know that it's not replacing y with 1/4 y and it flips the other way.
No, replacement is always the opposite. It's the reciprocal. Now, when I put it over here, it's going to be 1/4. Okay, when I put it on the right, I'm just putting it there for my replacement site. My x is becoming negative x. So I'm going to go like this, and I'm going to cube it. Correct? That would be the next step. And then, let's rearrange first before I do it. So just so you know, that's going to be 1/4. Can this negative come out in front? Like, is negative x all to the power of 3 the same as pulling a negative out front? Yeah, because a negative x cubed, the negative x quantity cubed is the same as a negative x cubed, correct? That they're all negative. So I'm going to put this negative in the front, just so I don't have to deal with it. And I'll show you why in a second. Okay, so that is the same thing. If I put the negative in the very front. Now I can deal with the translations 3 units to the right and not have to worry about that negative. So this is going to become, p of x is going to equal negative 1/4. Now let's move this x. When we go 3 units to the right, I have to bring it back 3. So we have to go x minus 3. And that is your final answer. So way easier to pull this negative out front and not have to deal with him. Okay, because it's the same thing. Okay. Let's do one and actually sketch it, since we haven't done that yet, and then we'll quit. Okay, so when I look at the transformations from y equals f of x, sketch the graph of the transform function y equals f of that stuff, this is where you have to be so careful. This 1/2 has to be factored out. If you look at on the very front page of this lesson where we had that big old x minus h stuff, the b is factored out. So you cannot, oh yeah, here it is right here. You cannot tell me that that's going to go 3 units to the left because there's a 1/2 in there that has to come out. So we must do this first. Don't ever forget this. Take the 1/2 and factor it out. By the way, what would be left in there? Half of what is 3? 6, right? So there's actually a translation, a horizontal translation of 6 units, not 3 units. So that's the most common mistake that happens. Okay? All right. So now we can do all these things to it. We can talk about what's happening. So we have a horizontal stretch by a factor of 2, exactly. We have a horizontal translation, and we're going to go 6 units to the left. Correct? And then we're going to go 8 units, so a vertical translation, 8 units down. Okay, so we can just do those things to it. We can do the stretch first and then do the translations in one step. We can go 6 left and 8 down, so I'll use different color. Horizontal, that means all the x values of every point are times by 2. So I'll start here. 1, 2, 3. This is -3. I'm going to times that by 2. It's going to go -6 right there. Okay, what used to be at 2 here is now going to be times by 2 is 4. Sorry, -4. Okay, what is at 0 remains. This point is at 3. So now it's going to go to 6. I had to show that first mark so those that are listening can hear or know what I'm doing. And this one, it's at 4, goes to 8. Okay, so we see our first picture. That's our horizontal stretch. And now let's take that in one motion. Let's take it left, 6 left, and 8 down. It's going to go off the page. 2, 3, 4, 5, 6. Approximately there, and then we're going to go down 8. Approximately there. Okay. And now we can do that with all of them. We can go this point here up at the top. Let's go 6 left. That's easy. And 8 down. Oh, it's at 8, so that's perfect. Right there. And then if I take this one here and go 6 left, that puts me back at 0. But then 8 down is there. And this one, you can even just figure out how this moves, right? I mean, you don't have to count every one. Do you see the pattern that this one goes over 2 and up 3? So I'm just going to go over 2 and up 3. You know what I'm saying? Okay. Okay, we're done. That's it. We can do this last little one here if you want. The function f of x equals the square root of x has been transformed into the function da 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 da. What do you think is the key here? What's the first thing? It's red lights. You're going to do it. Factor out the 3. So just totally rewrite this. Pull out the 3. Go x minus 4. Leave your plus 5 outside of the radical. So important. Okay. So it says the function f of x has been transformed by stretching it horizontally by a factor of what? What's the horizontal stretch? A 3 turns into a 1/3. Stretching it vertically about the axis by a factor of 2. It is what it is. Reflecting in the what? All the y's are changing, so you're right. It's an x-axis. Translating it how many units up? 5 units up. And how many units horizontal? 4 units horizontal to the right. Done. Excellent. Okay, and I'm done.